Hello and welcome. This presentation is an introduction to the Rubin Observatory's Legacy Survey of Space and Time, the LSST, annual data release data products. The LSST will be an optical imaging survey of the southern sky starting in a few years. This presentation describes the image processing and source detection and characterization that will run every year and the resulting annual data products that will be available for scientists to analyze. The Rubin Observatory's telescope and camera and its Legacy Survey of Space and Time, the LSST, have been designed to deliver its core science goals within 10 years. The science pillars of Rubin Observatory are described in a separate presentation. The schedule for the annual data releases over the full 10 years are as follows. DR1 will include data from the first half year of the survey. DR2 will include all of the data from the first year of the survey. DR3 will include all of the data from the first 2 years of the survey, and so on until DR11 includes all of the data from the full 10-year survey. It is important to note that it will likely take about half a year to process and validate each data release, and thus scientists should expect DR1 to be released about 1 year into the survey, DR2 at 1.5 years, DR3 at 2.5 years, and so on. When data is released, that means it becomes available to scientists in the Rubin Science Platform, the RSP. The RSP is a set of integrated web applications and services deployed at the Data Access Centers, DACs, through which scientists will access, visualize, query, and perform next to the data analysis of the LSST data products. The term next to the data analysis refers to how users will bring their analysis codes and visualization tools to the data and to the computational environment of the Rubin Science Platform because the data products are too large to download. The RSP has three main aspects. First, the portal aspect, which will offer exploratory interfaces and visualization tools. Second, the notebook aspect, which will allow users to create Jupyter notebooks in a curated environment. Third, the application programming interface, or API aspect, will allow remote access to the archive. For example, other science platforms or virtual observatories could use an API to automatically query the Rubin data release catalogs for observations at a given sky location. The Rubin Science Platform is more fully described in a separate talk. The annual data release data products will include both catalogs and images. The image types that will be available to users include processed visit images, co-added images, and calibration data. The processed visit images are the individual images from a single observation. They are astrometrically and photometrically calibrated and validated and have metadata from the telescope and site as well as the processing pipeline. The primary type of co-added image is one deeply co-added all-sky image per filter that has been optimized for depth and resolution with transient flux removed and the astrophysical background preserved. The template co-ads for difference image analysis will also be available, as will calibration data such as darks, flats, and biases. The catalogs that will be available to users include source and object catalogs, where sources refer to detections on a single image or coad, and objects are associations of sources at a given sky coordinate. In the context of Rubin data products, a detection typically means detected with signal-to-noise ratio of 5 or greater. The source and object catalogs that result from detections in difference images, which are produced by subtracting an older template image from a new image, are referred to as DIA source and DIA object, where DIA stands for difference image analysis. Additionally, force photometry will be done in all direct and difference images at the sky coordinates of all sources ever detected, including those detected only in a deep coad. These catalogs of sources and objects will include measurement parameters such as point spread function or PSF, shape, size, flux, and color, and characterization parameters such as bulge disk model fits, variability parameters, and photometric redshift estimates. It is anticipated that some science goals will require data products that are not produced by either the prompt or annual data release pipelines. For example, deep multiband detection coads, short period coads, or best seeing coads might all be necessary for some science goals. The Rubin Observatory Data Management System will provide the algorithms and tools necessary to create such user-generated data products in the Rubin Science Platform. This will enable users to make their own images and catalogs in formats that are consistent with and thus can easily be joined or co-analyzed with the LSST data products. Users will be able to either share or keep private their user-generated data products in the Rubin Science platform, and the implementation of mechanisms for properly referencing shared user-generated data products, such as digital object identifiers or DOIs, in the RSP are currently under development. If you have any further questions about Rubin Observatory, there are a variety of ways to find answers. First, please come back to the Vera C. Rubin Observatory booth in the exhibit hall of the 2021 Winter AAS meeting, where we would be happy to answer your questions. Second, please feel welcome to visit our online community forum at LSST or at community.lsst.org. This is the best place to seek answers for questions about the LSST data products, science pipelines, or the RSP. The contents of our forum are publicly available to search and read, and anyone may obtain an account in order to post questions or participate in the discussions. Third, if you're interested in getting involved in preparing for science with Rubin Observatory, you might like to join one of the 8 LSST science collaborations. The science collaborations are independent worldwide communities of scientists, self-organized into collaborations based on research interests and expertise. They are laying the groundwork necessary to prepare for doing science with the LSST data products and services, and are open and welcoming to all, especially to students. Joining a science collaboration is a great way to learn about Rubin Observatory. Fourthly, all of the LSST data products are defined in full in the data products definition document, which is available at ls.st/dpdd. This document includes descriptions of the images and catalogs, including tables of the catalog elements and their formats. Goodbye and thanks for watching.